My name is Roger Breu, or Roger. As Johan mentioned, I'm based in Switzerland and I'm working together with Henk in a Western Europe team. We are covering Switzerland, Austria, Belgium, Netherlands, Luxembourg, Sweden and Norway, which is a quite interesting territory. We are focusing solely on parallel data warehouse, on the parallel data warehouse solution, where I take over more the broader solution part, and Henk is my technical conscious. He will introduce himself more in the next session when he will also do some demonstrations on PDW. So this next 75 minutes will give you an overview on what parallel data warehouse actually is. And some of you might have heard already some announcements, especially those who have attended the SQL Pass Summit in Seattle, that there is a new version coming up, and we are about to show you some stuff there as well. So maybe before we get started, that we know a bit how the audience looks like. Who already knows what SQL Server Parallel Data Warehouse is? Good. Who had ever touched a parallel data warehouse? Okay, yeah, not much. Good. Who already knows what the new features or the new stuff are in Parallel Data Warehouse version 2? Who was at the SQL Pass Summit? Some? Okay. So I will also show you a little bit what the differences are from what is currently available and what is on the very close horizon. Further, what is the role you are in? Are you more like DBAs? Who's a DBA or architect? Okay. Who's a developer? Okay. And who's more in the business area, like being responsible for a specific application using BI? Okay, good. So I think we have a pretty mixed audience here, which is great. And I encourage you also to ask questions. The whole sessions will be recorded, and please remind me if I forget to repeat the question. But please feel free to ask questions. We might push some questions which could take longer towards the end, but of course Henk and I are also available during the break and after the sessions for additional questions. So, my short agenda, I will give you an overview on PDW in general, what it is, and especially around version 2. We will look at the architecture, and I picked out some database feature highlights which are coming with the next version. So, looking at parallel data warehouse from a very high level, what is it? And I will now start to use only the abbreviation PDW because it's a little bit easier than always say parallel data warehouse. So what is PDW? Basically, it is an appliance, as we will see later on, which is built for big data, not only in terms of functionality, but also in terms of performance and in terms of costs. Big data often means huge amounts of data, and you have to store them, and you can't store them on expensive storage or on expensive compute, and PDW is really built for that. The SQL Server 2012 PDW release, which I will sometimes refer to version 2, focuses on performance especially. So we had a huge design goal to make it 10 to 20 times faster compared to SQL Server 2008 R2 PDW. And this is one important point with the xVelocity column store. We achieved that goal. And it's a scale-out architecture basically for SQL Server running on industry standard hardware. We have our colleagues from HP here. It runs on standard DL360 compute nodes and standard storage, so there is no fancy proprietary hardware necessary to run PDW. So if you look at it a little bit more deeper, basically PDW is the MPP solution for SQL Server. And if I may use the whiteboard here, if you think about how a typical data warehouse looks like, if you start small, maybe with some gigabytes of data, maybe you start even in a virtualized machine doing some tests, but test systems or development systems tend to go into production. And what you typically have is you have a server, maybe 2 CPUs, and you have storage connected. Typically, this might be a SAN, because you have it, you have a corporate SAN, you might have a policy to use that corporate SAN. SANs typically are pretty expensive if you look at it from a price per terabyte, but of course they deliver some flexibility for grow, some really nice high availability or disaster recovery features. But the question is always, especially in a data warehouse environment, do we need those features? And do we get the performance out of such a system? Because typically what you see is that you get pretty beefy servers up front here. You have a pretty expensive SAN behind, but you still have only 2 times 4 gigabit connections in between, for example. So if you do the math there and see what kind of throughput you will get, you typically end up having a huge bottleneck in the connection here. So what can you do if you have more data, if you need more compute power? You can go here and just replace the server. If you need more storage, if your data volume is growing, you might just allocate more disks. But this means that basically the bottlenecks or the imbalance you already have here is growing again on one or the other side. So if you just add more storage here, you still have the compute power here with 2 CPUs with a certain amount of memory, and you still have the small connection in between. So in case you really want to scale balanced, there are also solutions available, and some of you might know the fast track reference architectures, which really focus on a balanced design, so that we know per core what we can consume of data, and therefore the storage and the SAN in between is designed accordingly. But basically what you can do is, if you need more or if you get more data volume or you need more compute power, you have to scale up. So the next step would be you use a 4 CPU machine. You need, of course, to add more memory as well. And to have it balanced, you need also double the amount of spindles, double the amount of connections to the disks, and so on. And if you still don't have enough data, or if you have more data volume and don't have enough storage available, or you need more compute, you have one next chance, which would be an 8 CPU machine with, again, double the amount of disk spindles and double the size of the whole storage network. So you're pretty limited in this, let's say, old world of an SMP environment. I call this typically vanilla SQL Server. So this is just when we install SQL Server somewhere on a box, and this is the SMP fashion. So SMP, symmetric multiprocessing, the only way to grow here is when we can scale up. And PDW, with its MPP technology, is different here. So basically, if we compare those two together, in PDW, we also get some small servers, 2 CPUs each, and we have corresponding storage behind. So basically the same as the fast track approach. If we now look at the new version of Parallel Data Warehouse, we have 2 servers sharing 1 storage enclosure with a certain amount of disk spindles. And instead of scaling up to 4 CPUs, what we do here is we spread the data across the nodes. So a very simple approach. Basically, we take the large fact tables, pick a distribution key, and Hank will show you that, how that works. And according to this distribution key, the appliance takes care of distributing the data to the nodes. So each node hosts a part of the larger fact tables. And of course, we also have smaller tables, maybe dimension tables. What are we doing with them? We can replicate them. So each host gets the replicated table. And this means if we run a query against the system, against the appliance, that each node is able to do part of the whole work. So basically what PDW, and this is not just PDW, but every MPP approach appliance is doing is we are taking a bigger problem and cut it into smaller pieces. And instead of running one query, as this server would do against a data set, we are running 8 queries per node. So imagine on this machine we have a 160 gigabyte table. You do a select on this table, you have one query scanning 160 gigabytes. On this system, 160 gigabytes, the table is distributed, so each node has 80 gigabyte, and we are running in 16 queries. So basically we have 16 queries querying each 10 gigabyte. And this is the whole, let's say, secret sauce of the MPP engine. We are really taking a larger problem and put it into smaller pieces, and therefore we get the performance out of such a system. So to complete the PDW architecture, despite the compute nodes, we have additional nodes, and in this case, and I will go back to the slides afterwards, the smallest configuration we have, or we will have with version 2, is a so-called quarter rack or a base unit, and this always consists out of 4 nodes. We have 2 compute nodes, 2 active compute nodes. We have one node which hosts control functionality, which is basically the connection to the outside world. So if you have an application like reporting services or any other application, this connects to this control node, and the control node basically abstracts the whole complexity of the nodes behind. So you don't see if you have 2, if you have 20, if you have 40 compute nodes. You connect to the appliance as if it would be a single SQL Server instance. And this was also my, let's say, my first impression I got from PDW when I touched it the first time some 2 years ago. I was used to optimize SQL servers. I was used to make sure that we have enough file groups, that everything is aligned to the storage, that the data growth is according to best practices to avoid fragmentation and all this stuff. And everything I used to normally optimize for customers is already done on PDW. And basically, PDW is easier to manage and to maintain than a single SQL Server VM, because you don't have to care about trace flags, care about file groups, care about data growth, care about fragmentation with growing log files and so on. The appliance takes care of that. So on the control node, additionally, we have some management functionalities, and we also have virtual machine manager running on it. And this shows, and this is new for version 2, that the whole appliance is basically virtualized. So we are leveraging newest capabilities of Hyper-V from Windows Server 2012, where we don't have any limits anymore, or almost no limits anymore in terms of resources. Before we had these 4 virtual CPUs, 64 gig of memory, and now we can grow up there to 64 CPUs and I think up to 1 terabyte of memory per VM. And this allows us to really make sure that we have a pretty low footprint in terms of hardware, that we also can leverage high availability capabilities from Hyper-V instead of using additional passive servers for that. And this, I think, is the most or the biggest difference compared to version 1, where we had a lot of passive nodes running in the system. So basically, we have a VM per compute node. We have some VMs running on the control node for the housekeeping stuff, and additionally we have a passive server for the high availability stuff. So in case one node is failing, the virtual machines are moved over or quick migrated to the passive node, and this solution also allows us to grow pretty easily if we have more requirements in terms of storage or need more compute power. So instead of just replacing the stuff here on the SMP side, we are able to add a module, or we have a modular configuration. We just can add 2 more compute nodes to the appliance, and can do a backup restore of the database, and the data gets distributed again across these nodes as well. And this allows us to grow up to 5 petabytes from a storage capacity. So I think this is mainly the difference here between SQL Server SMP and SQL Server MPP provided with PDW. So why does it come as an appliance? Yeah.
Is it possible do you have to grow with the same hardware, or can you change hardware?
So the question is if you can grow with the same hardware, if you can grow with different hardware, or if you have to use the same hardware. In the past, with version 1, you had to grow with the same hardware. But HP, or we are, as we are running on industry standard hardware, typically this hardware is still available also later on in time. As we are going to use virtualization for the next version of PDW, it makes us more flexible. To be honest, at the moment, as PDW version 2 is not even yet released, I can't confirm everything, but I expect it will be easier than it was in the past. Yeah. TempDB. Yeah, what happened with TempDB, or where is TempDB? Genau. Basically, on these compute nodes, we are running an instance of SQL Server. So each of these compute nodes has its own TempDB. This means also TempDB is spread across the appliance. And this was, of course, a bottleneck in the past. If you look at SMP, you typically also had some challenges when you just were blowing up TempDB or putting some logs and stuff on TempDB. And this is what we can address as well with the MPP approach by spreading the data across the different compute nodes. Does this answer your question? Yeah.
Release date, or the release date for this version 2?
The release date for version 2. Officially, it's H1 of this calendar year. So this gives us time until the end of June. We hope it will be available a little bit sooner. So we have a target internally, but I can't confirm it officially. The official message is still H1. Any other questions at the moment? Good. So my question was, why an appliance? Or why can't you just download the software, it's virtualized, run it on Azure? Why an appliance?
What is an appliance?
What is an appliance? Good question. So an appliance, basically, just to simply define it, is hardware and software pre-engineered and optimized for a certain workload. And this is exactly the reason why we have PDW as an appliance, because in the end, if you run a certain workload, you can do a great job in designing your database. You can do a great job in optimizing your queries. But if you run it on a small virtual machine, maybe it's even optimized and tuned, this virtual machine, but the hardware in the backend isn't supporting that specific workload, you won't get the performance out of it. I tend to say that typically the cable is the problem. It's either not connected or it's the bottleneck, and this is still the same. So an appliance might help to address this problem because we are predefining how it should look like. This means that especially for customers, it makes it easier to deploy a solution like this because it's pre-engineered. It doesn't take 6 months to test all the components out, to make sure that you have the right firmware, that you have the right configuration for the network cards and all the stuff. So therefore, an appliance. This gives you as customers or as partners who work with customers, let's say the Microsoft HP stamp of getting a certain performance out of that system. And this is also how it gets delivered. When it's delivered, the first thing the HP technician is doing is running a self-check on the appliance and checking that you get the throughput for which it is designed for. I think Henk has some screenshots on this as well afterwards. So that's the reason for an appliance. We want to make sure that you get predictable performance, that you get the performance you paid for out of the system right away before or without doing any additional tuning on the box. What is also a point for an appliance is that we are able to offer you a single point of contact in terms of support. I'm sure you have been in the situation already that you had a problem, something was running slow, and it was not clear what it was. The developer said, it has to be the SQL Server. I know it's that. SQL Server is crap anyway. Go to Oracle, whatever. The SQL Server DBA said, no, it's not SQL Server, it's the storage. The storage guy said, no, it's the network, and everyone was finger pointing at each other. And I think this is also an advantage of an appliance because there is one responsibility for the appliance. And in this case, it is Microsoft. So even if a hard disk fails, if it blinks red, you can call Microsoft, and Microsoft orchestrates the support and the replacement together with HP. And I think this is also an advantage and can, especially in a mission-critical environment, be of huge benefit if you have one single partner who knows the overall solution, and he can only know it, of course, when it's completely configured like it should be, and this is why it comes as an appliance.
Just
a
rough figure about the starting point for the cost.
Mm-hmm.
Let me position it a little bit better.
You are asking for the cost of the appliance. I'm coming to that on some slides. I will give you some ballpark figures. Of course, this has to be looked at from project to project, but I can give you some ballpark figures. So basically, an appliance allows you to have a fastest time to market because it's pre-engineered, it's pre-configured, it's pre-everything, and it allows you to start small and grow when you need it. Grow up to 56 nodes. So if we look at the hardware configuration, or basically how it looks like, we had some key design elements, especially for version 2. It needs to be more modular than version 1 was. On version 1, you had the ability to buy a half-rack configuration, which was basically 1.5 rack, because the whole housekeeping stuff was in its own rack, and the data rack was running with 4 active compute nodes. The next upgrade step you could do was go to a full rack, and then you would add additional racks to the appliance. So it was already scalable. You could start mid-size and grow large, and with version 2 the target was really to start small and grow even larger. We also wanted to leverage the latest Microsoft software features, as I mentioned, Hyper-V. Also a huge advantage we are getting out of the storage spaces functionality, which makes sure that we have all the security and the rights on the disk level. So this is moved to the Windows Server part. We don't use any storage controller for having the right configured. And a huge database feature which is coming with PDW version 2 is the xVelocity column store, or the column store index, or VertiPack, or whatever name you heard before, and it has some advantages over vanilla SQL Server. We will come to that. So before, when I draw this 2 compute node appliance, this is basically the starting option. It's the base unit, it's the so-called quarter rack, where we have these 4 servers, the storage, and everything is connected with high-speed InfiniBand. We have around 32 cores actively running workload, a half a terabyte of memory. We have around 40 terabytes for TempDB and up to 256 terabyte of user data. And this is, of course, compressed data, and we are getting a high compression out of the column store, which I will come later on. I explained already how it looks like on a logical level. We do have virtual machines, compute nodes running here on hosts 2 and host 3. They are working against the storage spaces, which basically, from a hardware perspective, are direct attached SAS disks. And we do have host 0, which is responsible for the housekeeping, control node, management node, the Fabric Active Directory, and the virtual machine management. Basically, the whole configuration forms a huge failover cluster. We are running Windows Server 2012 and SQL Server 2012 on it. In terms of high availability, we are leveraging Hyper-V mechanisms. So if host 2 fails, the virtual machine will be moved over to host 1, and it will connect via RDMA over InfiniBand to the storage spaces disk. Start small. The quarter rack again. When we need to add capacity in terms of compute or storage, we add 2 more nodes with the corresponding storage. We can further add 2 nodes and storage until we have filled up a rack, and then we can start with the next rack. So in the end, you can really start from a small amount of gigabytes or terabytes up to 5 petabytes. And this is, of course, compressed space we are using there, and I will give you some insights on how this look like on the next slide.
Comment then.
Yeah.
Maybe you could explain how this left figure is a quarter rack, that they are empty things, because not everyone understands that, I think.
Okay, yeah. So let me briefly explain what this is, especially for those sitting at the back. When you buy PDW, you get it delivered in a rack, pre-configured, pre-cabled, set up, and it will be ready to run in a few days. What you get basically are the compute nodes and the storage, plus on the upper side here, the control nodes and the passive nodes with all the network capabilities. And you have a lot of empty space in the rack. So if you need to upgrade, you go there, add another module, a so-called scale unit, 2 compute nodes, corresponding storage, and put it into the same rack. What is also possible is that you put some external services you have been running before into the same rack and attach it to the appliance internal InfiniBand bus. An idea for that could be an analysis server needing the data from the relational data warehouse. You can also run in a roll-up mode and use the InfiniBand network to be really fast and really close to the appliance. This is coming back to my point I made around the cable. In the end, if you need to process a cube, you are mostly limited by the network connection in between if you have enough CPU power. And InfiniBand can help you there to get the data faster. And we have been running some POCs where we just got 3 times better performance when we connected the analysis server to the appliance internal InfiniBand bus.
Question
Yeah.
about the SSIS connections.
Yeah.
Do you have any special optimizations on that?
The question is on SSIS connections, integration services, and if we have any special optimizations for that. We do have specific connectors to PDW, and I'm not sure if you have a picture on that and show something as well. Demo that. I think the most important point is that if you used SSIS, for example, against a fast track machine, you needed to create packages with parallelization. So you need to create the parallelization on your own. If you connect to PDW, PDW takes care in the end, in the back end, to parallelize the inserts or updates or deletes. I think the more important question on integrating data into a solution like this is if ETL is still the right way, or if you should move to an ELT approach. So just drop all the data somewhere, load it to the appliance. It is very fast in loading flat files, and then do the transformations on the appliance by leveraging the MPP capabilities. I think there you can see a lot of benefits using PDW. But SSIS, all the other Microsoft BI components integrate very well with PDW, as well as third-party products like Tableau, MicroStrategy, and so on, do have specific connections to PDW. So to give you some figures, again, we've seen here the base unit, as I mentioned. We upgraded to a half-rack configuration like this, having 4 compute nodes with a raw capacity of around 30 terabyte, and this gives us up to 512 terabyte user data if we use the full compression capabilities of the column store. And as I mentioned, we can grow up to 7 racks with 56 compute nodes at the moment. To come back to your question around pricing. So what would you expect did a PDW version 1 full rack cost? This is the picture you see on the outside of the room, where you have 2 racks, you have 6 servers for the control stuff, and you have 10 compute nodes plus a spare. What would you expect? You have around 17 servers, you have around 50 terabyte storage capacity, some guesstimates. So it's around $1 million list price, the hardware. And if you look at the very same configuration, the full rack configuration on version 2, this is somewhere around 60% of the costs. If you look at the smallest configuration, this is somewhere around $300,000, just to give you some ballpark figures.
I'm talking about the hardware price.
Yeah.
So what about the software price?
The software price is, as always, it depends. So, of course, it depends on what kind of contracts you have with Microsoft, but typically it is a fraction of the hardware price. So if you
compared to Vanilla SQL?
To Vanilla SQL, it is basically SQL Server Enterprise from a price perspective, and for this configuration you need 4 CPUs or the 32 cores.
What about high availability between data centers?
Mm-hmm. High availability between data centers, or this would more than be a disaster recovery scenario maybe. This can be achieved by, for example, running a dual load strategy. This is what we typically see in projects. Basically, you dump the data to load on a certain server, which gets replicated to another data center, and then you run the load job again in the second data center. This gives you also the advantage that you can load the data into the second appliance with a delay, for example, of 3 hours, which makes sure that if you have any problem or someone dropped by accident a table on the first machine, you still have it on the second machine. Or you can do backup restore. That's also possible. But the question is always, and then we are again with the cable, how many gigabytes or terabytes are you able to transfer from one location to the other? But disaster recovery scenarios with this is typically created with 2 appliances, 2 different appliances, where you do a dual load strategy.
What about SQL licensing when you have multiple data centers?
That's a good question. What about SQL licensing when you have multiple locations? If you look at it on one box, you basically already have the disaster recovery options used, because you can failover internally. So this means that you need the same licenses again for the disaster recovery side. But there are some options available with software assurance, but I don't think I have to go too deep into the licensing part, but I'm happy to discuss later on how it could look like. There are options available. But typically, disaster recovery is done with 2 separate appliances. This gives you also the ability when, for example, a software update comes, and we call it appliance update. This means it can update the firmware, it can update the operating system, it can update the SQL Server engine, all with one setup routine that you can run it on, for example, disaster recovery appliance first, and then if everything goes well, you run it on the production appliance. Okay. So let's move on to some database feature highlights. Who knows the column store index in vanilla SQL Server? Good. Who worked with it? What were the query improvements you have seen? 5 times better, 10 times better, slower? 10 times, roughly. Okay, yeah. So this is also what I experienced with some customer workloads. I have had a very interesting project at a large Swiss customer which was using Siebel on SQL Server. They often had some performance problems, but not because of SQL, mainly because of Siebel and how it was designed. And of course, Oracle always tried to push some Exadata stuff in there because they said, yeah, it's SQL. And we just did some column store indexes on that machine, on a test machine, which was actually even lower in terms of hardware resources. And we got a 15 times improvement on almost all the queries. So the 15 times was more or less the average. And this made the customer standing on SQL Server and going to SQL Server 2012 even without having any official support from Siebel side. But it worked really, really well. So with PDW version 2 or SQL Server 2012 PDW, we will also have the column store index available. As I mentioned in the beginning, we will even have some advantages. And the biggest advantage is that we get a clustered column store index, which means that we can directly store the data in the columnar format. So we don't need to store it in the row format and then create an additional index which needs additional storage, although it's highly compressed. So we can directly store it into columnar format. And this is where we get huge compression ratios out of it and also huge performance improvements. And we will have some videos on that as well, how it looks like in terms of performance. All those of you familiar with the column store index know that it was optimized for running in memory as well. So if we look at the smallest configuration with around 0.5 terabyte of memory and have a, let's say, conservative estimate of around 5 times compression, you can run with a data set of around 2.5 terabyte in memory against the appliance, which is really, really huge and allows us to be up to 50 times faster compared to what we had on previous versions. So I think a big advantage of the column store index as well is that we can really go into the direction of real-time data warehousing. It can even sometimes eliminate the need for cubes. Sometimes you only have cubes to get faster performance. And if you can do this already on the relational engine, you have a big advantage. I don't say at this stage that PDW will replace all the cubes. Absolutely not. There is still a lot of needs for cubes. But for certain cases, you might be faster or at the same performance to run the query directly against the relational data warehouse instead of getting the data first out to a cube, process it, and run it against that cube. One of the biggest advantages I see in the column store index are clearly that if you have a column store index, you basically don't need these other 50 non-clustered indexes on that table anymore. This means you save on storage, you save on administrational effort to keep these indexes up to date and maintaining these indexes. So if you look at SQL Server 2012, vanilla SQL Server, the column store index we get there is non-clustered, but we see a large performance improvement. Of course, we have to make sure that our ETL processes are aligned so that we drop the indexes, then update the tables or work with partitioning and partition switches and so on. But it works, and it typically doesn't require any changes to queries. So we can just run the same queries against the table, and PDW and SQL Server optimizes it according to the column store index. But we do have two major limitations. One limitation is that it's only available as non-clustered index, as mentioned earlier. So it is additional storage needed, and it is not allowing updates. And PDW exactly addresses those by having a clustered column store index, and this is the primary storage for PDW. So if you create a table, this is the default storage mode for PDW. It will always create a column store table, if you will. And the clustered column store index on PDW is, of course, updatable. So if you look at it from a technical perspective, there is a so-called delta store running as row store. When you insert and update data, it runs against this delta store. If you do a select, then it unions the column store and this delta store together. And to make sure that the data you have inserted is available as the clustered column store, you need to reorganize the indexes. So here we introduce some maintenance which needs to be done, but I think it's worth doing it because in the end you get so much speed out of that feature and you can really compress your data pretty well. Yeah.
Does this mean that even dimension tables are column store tables in parallel data warehouse?
Yeah, the question is if even dimension tables are or can be column store or column-oriented tables in PDW. Yes. So you can not always. I mean, you can choose. That's the nice thing here. You can still create a classic row store. If you don't create a column store, a clustered column store index on a table, it's a traditional row store. But you have the choice. And it can be either a replicated or a distributed table, and it can use the column store index functionality.
So the column store index will support replication as well, if you choose the column store and the separation of the dimension tables?
Yeah.
Okay.
Yeah. So basically, this is something which the appliance is doing for you. You don't have to care where the data goes. You will see in the demo from Henk how you define a table. You define it's a replicated or it's a distributed table. And in the end, if you load against that table or if you insert or update, you don't have to care what happens behind. This is the appliance which takes care of that.
One question.
Yeah.
The CCI reorganize, is that happening automatically?
This is is the cluster column store index reorganization happening automatically or not? No, this is basically like you would have it on a vanilla SQL server. You run some kind of index maintenance jobs against the appliance. And the reason for this, just to come back to that, you might have experienced that if you create a column store index, it takes some resources to create it. So it might be a good advice to use maxstop1 or some other configurations to make sure that your server is still responding when you're doing this kind of stuff. And this is also the reason why you can do it here manually. You can also assign certain resources for these operations and make sure that you don't overload the whole system and that it's still responsive. Yeah.
Is there any kind of resource governor?
Is there any kind of resource governor? Yes, there is. Basically, in version 1, in 2008 R2, the resource governor was used under the hood. So the appliance was pretty fair. Each query, each workload running against the appliance got the very same resources, same amount of CPU cores, same amount of memory, and so on. So you couldn't really adjust it, which was good in terms of manageability. You didn't have to care about that. But of course, there are some workloads for which you would like to assign more resources. Maybe you would like to guarantee that a certain report runs faster than others. You would like to guarantee certain resources to a specific group. For example, the executives, they should get some more or the DBAs, they should get some more resources than the others do. And we expose this functionality in version 2 as well. So this is also a new feature in version 2, the workload management.
One more question about the column store index. There's a limitation of the data type size in SQL Server 2012. Is it the same for this?
Question.
The money type,
yeah. The question is, are there the same limitations in column store regarding the data type size like in regular SQL Server? Yes. There is another point here. PDW has some limitations in terms of data types. So you don't have all the data types you have on regular SQL Server, like varchar max isn't available on PDW. But typically, this is also not data you would like to load into a data warehouse. But all the data types supported in PDW are supported in the column store index as well. Okay. So I think we already discussed this. Basically, what gives us the column store and the clustered column store, it is updatable, it's primary storage. We have a better compression. This 3 times is very, very conservative. Typically, we see 5 or even 10 times compression relative to what kind of data you are having, and also the query performance is at least 10 times typically compared to without running with the column store index. And the advantage is definitely the reduced need for pre-built summary aggregates, and it might even eliminate some cubes in certain scenarios. Let's go to the next topic, and this is big data, a huge topic, pretty fancy in the media. Everyone is talking about big data, but I would say that not a lot of customers are actually really working with big data, and each and everyone defines big data a little bit different. We have customers who say, if we have 50 gigabytes and we can't analyze these 50 gigabytes in 10 minutes, we are talking about a big data problem. We don't have to have petabytes of data to talk about a big data problem. Some Swiss banks I'm working with say big data is just a new word. We are having these challenges already since 10 years. So yeah, it's nice to have a new word on that. But what is very fancy in the big data area, and don't understand me wrong, I don't say it's just the hype. It's really interesting and important what you can do with it. And I think the whole discussion around Hadoop and HDFS is getting more and more critical. We see a lot of customers starting to work with Hadoop. For example, one customer, a manufacturing customer, which wants to analyze all his production logs and wants to make better quality out of his processes. They collect around 7 to 8 terabytes of log files per day. And they use Hadoop basically to crunch these log files to separate the relevant from the non-relevant data. Basically, they use HDFS or Hadoop as some kind of ETL up front to make sure that they only have the relevant data. And then they load around 700 gigabytes per day into PDW to further analyze it. We often talk about non-relational or unstructured data and structured data. And this is exactly the challenge. How do you integrate it? Because in the end, if you need to analyze it, you need to structure the data somehow. And the only way you could do it before is if you were using some Hadoop stuff, some HDFS environment, you would have had to import it into a data warehouse system. There are some connectors around. SQL Server has a Hadoop connector, but the challenge there is how fast do you get the data from one system to the other? So the question is again, how fast are these two systems connected, the cable, and how fast do you get the data out? And typically, in the past, we had one connection crawling the data from the Hadoop environment and loading it into a data warehouse system. So what do you need to do to embrace big data today? Typically, you need to learn MapReduce. You need to understand Hadoop. You need to integrate this data into your data warehouse, and then you are able to analyze it. PDW brings a new functionality for this area, and it's called Polybase. Who has heard about Polybase already? Some. Okay. Polybase, simply speaking, is a translation between T-SQL and Hadoop, or T-SQL and MapReduce. So Polybase, as part of SQL Server 2012 PDW, is running on the appliance and allows us to connect to a Hadoop cluster and load data in parallel from this Hadoop cluster, or just query the data and only work with the active data set, for example, and move that data over in parallel to PDW. So basically, what you can do is you can create a select query joining a relational table on PDW together with Hadoop, together with some files on Hadoop, without creating a MapReduce job. And this brings us really close to Hadoop and offers also some new capabilities. For example, we can use a Hadoop environment to archive data. Typically, a Hadoop cluster is built on really cheap hardware, cheap storage, and we can push that data out to a Hadoop cluster to archive it and have a warm archive available to query that data. So we can use our existing SQL Server skill set. We save time and costs, and we can analyze all data types, be it structured, be it unstructured. And I do have an example available for that as well. Also, what this allows us is that we can integrate the data later on pretty easy into familiar tools like Excel. If we are speaking about big data and are speaking about petabytes of data, the power user working with this data, they typically don't want to work against 5 petabytes of data or query with Excel and some Hive add-in stuff, a Hadoop cluster. They want to get the data prepared. They want to use Power Pivot, Power View, maybe some other stuff. They use familiar tools like Excel to really analyze that. And PDW allows us to really simply integrate all these data sources together. How does it work? Just to give you a quick example here, it's a feature called external tables, and you can think of it as a linked server, maybe. So on PDW, you create an external table, give it a name, give it a location, which basically is the Hadoop cluster, and then you are able to query against that table. And I think I hid this slide. I just bring it here. What are the use cases for this? first case would be that you just query a relational table and join it together with data from a Hadoop cluster. So you just select and reference this external table like you would do it with a linked server. What you can also do, you can still, of course, import that data, and this is done as creating a table as select. This is a so-called CTES statement on PDW, which you will see a lot, I guess, in the demos of Hank afterwards. So you can import that data into PDW. Or the third use case, which I mentioned before, is some kind of archive, for example, where we can create an external table again and select the data into that external table. So basically, you push the data out again of PDW onto an HDFS environment. Who works already somehow with Hadoop? Who has been exposed to Hadoop? Nobody? Who's planning or thinking that in the near future might be working with Hadoop? Maybe someone? Okay. But I think there are pretty interesting scenarios possible. And if big data is a topic for your company, I really encourage you to look at the capabilities of PDW and see how you can leverage them for getting faster results. As a summary here, we have external tables where we can query across PDW and HDFS. We can parallel import and export from and to HDFS. And this is done by each compute node is speaking to one or many HDFS nodes. Instead of just one connection where we pull the data off, we get the parallelism there as well. Question again remains, how fast is the connection between those environments? We support various distributions of Hadoop. It doesn't have to be HD Insight. It can also be any other distribution running on any Linux environment. So we are really open there and integrate with all kind of Hadoop distributions. Important, it has to be Hadoop 1.0 and or 2.0, but there are not much limitations otherwise. Good. This brings me to the last feature. I already talked a little bit about it, but I thought it would be still worth to mention. It's workload management. And as I said before, PDW version 1 was pretty fair and just had all the very same resources assigned to all the queries and all the workload running. And PDW version 2 allows you to really assign the workloads or the resources with resource governor, with the methods you already know, to several workloads. So if you want to assign more resources to a load job, you can do that with PDW. If you want to assign more resources for doing some index maintenance stuff or turning a row store table into a column store table, and you need to be very fast, you can do this with the resource governor features you are familiar from vanilla SQL Server. So this brings me to our big picture, or the big data picture as we call it, which is a very busy slide, and it might be tricky to read it from the very end. But basically what we are seeing here is a high-level architecture on how a BI environment can look like or does look like. And it might involve big data, it might involve unstructured data, but typically, if we look at the traditional data warehouse environment, we integrate ERP, CRM, some line of business application. We have enterprise integration tools like SSIS, supported with DQS or MDS to load that data into a data warehouse, and then we create several data marts. With SQL Server, we can create a fast-track data mart, we can use reporting services, we can of course use cubes against that, and in the end, we would need to, or we would like to create value out of that data, and we would like to present this data to our power users with SharePoint, with Power View, with Power Pivot, and so on. The real big advantage with PDW is that we are pretty close here, having PDW as a hub and some fast-track data marts, for example, connected to the InfiniBand bus. So we can push the data out really, really fast. What is also important, if we look at the big data part where we have HD Insight on either Windows Azure or HD Insight on a local environment, what we will see sooner or later is that these two worlds, this Hadoop world and the PDW world, are merging more and more together. And this eliminates also the bottleneck we had with the connection here in between. I mentioned that PDW is already virtualized. So if you look at the long-term vision around how PDW will look like, you can easily see that you might be able in the future to run additional workload, non-parallel data warehouse workload on the very same appliance. Also, if you need to integrate big data, what is definitely worth to look at is the whole Stream Insight capabilities, where we already now, of course, can integrate sensors and device data and stream that data pretty fast into a data warehouse environment. So in the end, I think this is a good picture for you also to see in which area you see some improvement or some projects coming up. And we think that PDW can really be the heart of that solution because it delivers some great functionality, predictable performance, and scalability out of the box. And this brings me to my last slide. With the question, why PDW when I have SQL Server? And I'm not sure what your experience is, but if you run a SQL Server data warehouse, you might run very well, you have great performance, but you also have a pretty big effort needed to keep that data warehouse performing well, especially if the data volume grows. It might run well up to 5 terabytes, but if you add another 5 terabytes, does it still run well? Or do you have to change certain options? Is your night long enough to load all that data? All these questions come up if it grows. And with PDW, you are really able to tackle these kind of challenges with its MPP capabilities and with its parallel query performance we can achieve there. Will you talk about the POC we've run? So Henk will also give you some insights on how an SMP system compares to an MPP system in terms of performance and scalability. There are some new features coming up in the area of big data with Polybase, which are definitely interesting, and the updatable xVelocity column store, which is first available in PDW, will come later on in the vanilla SQL Server as well, but now it's only available in PDW. I think is a great advantage to save on storage costs because of the huge compression, but also delivers high performance for queries. And last but not least, the appliance simplicity, hardware and software engineered together, fastest time to market. I think it can also help to de-risk some projects. So you don't have to think about the scalability later on. I wouldn't say that PDW just scales for every query, and that you don't have to do anything, and it is definitely not self-healing and self-tuning, but it's a great way to scale out an environment, as we have shown there on the whiteboard. And it comes with predictable costs. There is no hidden cost into it. If you need to scale it out, you add another module with 2 compute nodes and the storage, and you always know how much it is. With this, I'm at the end with my presentation, and I think we can take some other questions, and we'll start the break around 3, or maybe already go before to the break.
Yes, I think it's we have 15 minutes left for questions. So, or is maybe everything crystal clear? So, yeah.
Mm-hmm.
Yeah, I got a question. What will be the reason to go from fast track to parallel data warehouse? What consideration will I do to make that move?
So you're asking for the reason from fast track to PDW, or what the implications are?
What are the decisions to make this move?
Okay, so the question is, well, what is the decision, or what is the comparison maybe between fast track and PDW? I think a most important point is the workload, and it's not the data volume. If you look at fast track, how it is sized, typically you say we expect a 10 terabyte data warehouse. So this fits to a 2 CPU fast track machine, the smallest fast track. The biggest fast track machine, the HPDL 980, can support up to 90 terabytes. But that's only the data volume. The question is, how fast do you need that data analyzed? And there is where PDW can just really give you the big advantage of the MPP architecture. So typically, if you compare a single box, 2 CPUs, to a PDW where you have 2 nodes, it's not just 2 times faster. It's typically 6, 8, or even more faster. And it's scalable. So one point is exactly what are you doing when you run out of disk space? On a fast track machine, you cannot just add additional disks, because then you're out of balance. With PDW, you would add another scale unit. Of course, you add compute power to it to stay balanced, but you get the option to do that pretty easy. Another point is, how do you tackle high availability in a fast track environment? You can cluster it, of course. You can maybe work with database mirroring. But these are all questions you would need to ask, which are already answered with a PDW solution. And last but not least, it's also a question on price. And if you compare a 4 CPU fast track with a base unit PDW with the quad rack, PDW is cheaper.
What is the reason not to choose PDW?
What is the reason not to choose PDW? Great question. I think there are some reasons, or there are some points where PDW might be, let's put it like this. If you have an existing system, an SMP system, and you want to move to PDW, you have to do migration. So it's not just backup database, restore database. You are moving from an SMP architecture to an MPP architecture. So this is what you have to keep in mind. This means that every time you put a PDW in there, there are some migration costs, some migration risks. If you want to avoid these, you can't stay, or you have to stay with your existing system. But if you need to grow, if you need to scale, if you need to be faster, this is a step which might be necessary.
But that is the same issue if you go in with a fast track solution. You need to migrate, you can't just back up restore.
Exactly.
If you compare to the fast track.
Yeah. But I think for PDW, especially with version 2 and with the base unit available, we have a great option to use it also for smaller environments. In the past, if you looked at the official messaging from Microsoft around PDW, we always said it's the solution for tens and hundreds of terabytes of data. Yes, it is, but it's also a solution for smaller amounts of data. We've been running a POC for a customer with 200 gigabytes of data on a 10-node PDW system and saw huge improvements. So it is not just for the hundreds of terabytes of data, it is also for the smaller amounts. And with the base unit, we have a great package available for these smaller environments. So it's not a $2 million investment upfront anymore. You can already start smaller and leverage the power of the parallelism. I'm sure there are other reasons, but I don't know them at the moment. Any other questions? Everyone is looking for the break. With that, thank you very much.